Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials. Please, as you watch this video, endeavor to subscribe, like, share and comment so that when I upload new content, you would be notified by YouTube, alright? So in today's class, we shall be discussing mathematics, that is MTH 101, topic sets, and this happens to be the first chapter of MTH 101. Alright, so we are going to be looking at what a set is, and we look at some types of sets. Then in our subsequent videos I shall be looking at other types of sets as well as exam questions. Okay, now what is set? S When you hear the word set in mathematics, a set is a well-defined collection. It's a well-defined collection of numbers. Alright, numbers, quantities, and figures. Alright, a set is a well-defined collection of numbers, quantities, and figures. Now, these numbers, quantities, and figures that are collected, alright, we call them elements of a set. So all the members, a set is a well-defined collection of numbers, quantities, and figures. It therefore means that these are the elements of what? A set. It means all members of a set are called the elements of that set. Say for example, if I'm having, and you should note that every set in mathematics is denoted using a capital letter. Set is denoted using a capital letter, while the members of a set is written or demonstrated or denoted using a small letter. Alright, you cannot use big letters to express the members of a set. You can use a capital letter for a set, but a small letter for an element of a set or member of a set. Take note of that. And you should know that while expressing a set, you don't use this curved brackets. No, you use coily brackets like this. This is how to express what? A given set. Alright, so if I have 8 equals this, maybe 1, 2, 3, 4. Alright, this is set, and these are the members of this set. So all the 1, 2, 3, 4 being the members of the set are called the elements of what? Set A. I believe that is clear. So a set is a collection, a well-defined collection of numbers, quantities, and figures, and all the members of a given set are collectively called elements. Okay, now let us look at some examples or some types of sets and how they are symbolized. Okay, now the first one is universal set. All right, so a universal set is a set that contains all, take note of this word, all members, that contains all members in a given problem or situation. All right, so a universal set is a set that contains all members in a given problem or situation. Now, how do you denote a universal set? The symbol This symbol of this is used to denote a universal set. All right, in mathematics, as regards sets, when you see this symbol or this, it means that telling you that you are referring to what? They are referring to a universal set. So this sign or this sign stands for what? A universal set. Please take note of that. All right, so the second one is subset. Subset. I'm going to be using examples to explain it better. So if I have two sets, for example, if I have set A and set B, I have 1, 2, 3, 4, 5, 6. All right. I have 1, 2, 3, 4. Subset. When we say sub, it means under. That is, when we say subheadings, they are smaller headings. They are smaller topics under the major topic. So when we are saying subset, they are sets found in another set. That is to say that if I have set A and set B, I have 1, 2, 3, 4, 5, 6. I have 1, 2, 3, 4, right? So the question is, please, subsets is denoted using a symbol. In set, when you see this, it presents what? Subset. If I'm having A to be this and B to be this, all right, I'll say that B is a subset of what? A. Why is B a subset of A? Because all the elements found in B are found in set A. You cannot say A is a subset of what? B. Because all the elements found in A, they are not found in B. So B is a subset of what? A. Because all the elements found in B are found in set A. So B is a subset of A. What if I'm having C? Hold on. What if I'm having C to be 4, 4, 9, 3. So A, B, C, I have C to be 4, 9, 3. Now the question is C a subset of A? Is a question. Is C a subset of B? Is a question. Now let's analyze it. Of course, set A is a subset of B because all the elements found in B are found in set A, right? So set C, I have 4, 9, 3. Is B a subset? Okay, that is the one we just analyzed. Is C a subset of A? The answer is what? No, because all the elements found in C are not found in A. You have 4 here, you have 4, you have 3, you have 3. But 9 is not found in A. Therefore, C is not, when you say it's not, you cross it. Therefore, C is not a subset of what? A. Because all the elements found in C are not in set what? A. Let's check the third one. Is set C a subset of B? Is set C a subset of B? Now let's look at it. I have 4, I have 4, I have 3, I have 3. So C is not a subset of what? B. Why? Because you don't have 9 in sets B. So please take note of that. This symbol is used to denote a subset of a given set. So please take note of that. And when it is not, you cross it. Okay? So that is for that. The next one is null or empty set. When you say null, so null or empty set is a set that contains no member in it. It is a set that contains no member in it. A null set is denoted using an empty curly sign or this. If you have this, have it nice, you don't have any member on the inside of it, it means the set is empty, or it is null, or this sign. What if, example, if I have all professors in BUK, all the professors in BUK under the age of 2 years. All professors in BUK under the age of what? 2 years. Such thing, guys, this statement is erroneous. All right, you cannot have professors who are below 2 years old. You can only have them above 2 years old. Such set is what? A null or what? Empty set. Because you cannot have such professors in Uniben who are below 2 years, who are below 2 years. So please take note of that. A null or an empty set is a set that does not contain any member in it, or that does not contain any element. It is denoted using this coily sign or this. That is null or empty set. The next one is union set. The union between set A, when it's good we use examples to explain for a better understanding. I have A, I have B, I have C, I have D, I have E, and I have what? F. Then I have Alright, this is set A. I have A, B, C, D, E, F, then B, G, H, I, J, C, B. Now the union of a set, or the union between two sets, is a combination of the two sets without any repetition. Union, what is the meaning of union? Coming together. So when you say union set, refer to sets that are expressed when the elements are joined together without any repetition. That is, if I'm having A, B, C, D, E, and F, and I'm combining this with this, it means that none of these elements should be repeated twice. Now the union of a set is noted using the sign. Alright, this sign is denoted using, union of a set is noted using this sign. Alright, when you see this sign in set, they'll ask you for the union of the set. So if they should ask you what is the union of set A to B, what will you do? A, B, C, D, E, F. You write it out. A, B, C, D, E, F. Now come to B. Should I write C again? Should I include C? No, because C is already contained in this set. So this one is out of it. So E, F, okay, G, H, I, J. Should I write B? No, because B is already in set what? A. So the union between two sets simply means the combination of all the elements in the two sets without any repetition. So the union between set A and set B is illustrated as this. You join them together, you combine them together. So take note of that. Now the next one is complementary set. Complementary set. Let me use this to explain it. If I'm having a universal set like this, I have it to be maybe A, B. Let me use figures rather. 1, 2, 3, 4, 5, 6, 7. And I have A to be maybe 2, 4, 6. And I have C to be maybe 4, 5, 6, 7. How do you now determine the complements of this set? The complement of a set is written as A raised to power C or A prime. Alright, A raised to power C means the complement of A. A prime means the complement of what? Set A. If you don't have it to be this, you have it to be this. If you are looking for the complement of C, it becomes C raised to power C or C raised to power what? Prime. Now the complement of a set is shown like this. I have this universal set 1, 2, 3, 4, 5, 6, 7. Set A I have 2, 4, 6, and set C I have 4, 5, 6, 7. 4, 5, 6, 7. The complement of set A simply means that I should remove all the members of set A from the universal set. Whatever I have left becomes the complement of set A. That is, I have 2, I'll remove 2 from here. I have 4, I'll remove 4. I have 6, I remove what? 6. So the complement of set A becomes 1. I'm not writing 2 because 2 is here. Okay, I'll write, okay, 4. Okay, 4 is here, so I'll write 3. What about 6? 6 is here, so I'll write 5. I'll write what? 7. So the complement of set A simply means that I should remove all the elements found in set A from the universal set. So whatever I am having left becomes what? The complement of that set. Okay, so then the complement of set C, it means that I should remove all the members found in set C away from the universal set. So let me remove this dotted sign here. So I have 4, I have 4, I have 5, I have 5, 6, 7. So the complement of set C, this call this sign here. Okay, the complement of set C becomes 1, 2, 3. 1, 2, 3. So that is how it is. Very easy. So how do you get a given complement? You get the complement of a set by removing all the members of that set from the universal set. So please take note of that. It is denoted using small letter C as a superscript or as prime. Okay. The next one is what? Cardinality. Cardinality of a set. Now, the cardinality of a set simply means the total number of elements contained in a given set. The total number of elements contained in a given what? Set. Look at, if I have this, I have 1, 2, 3, 4, 5. All right, and I have B. I have a B, C, D, E, F, G, H. Then I have C to be maybe all even numbers between 4 and 10. All even numbers between 4 and what? 10. So for me to get the cardinality of A, the word cardinality, I told you, it means the total number of elements found in a given set. So these are the elements of the set. So now please, the cardinality of a set is written as this. So the cardinality of set A becomes 1, 2, 3, 4, 5. So it is 5. You see that? Very easy. Then the cardinality of B, 1, 2, 3, 4, 5, 6, 7. 7. Then the cardinality of C equals, now please, between 4 and 10, you are not to include 4, you are not to include 10. So 4, what is the next one? 6, 8. So the cardinality of set C is just what? 2. So the cardinality of a set simply means the total number of elements found in a given set. 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5, 6, 7, 7. 1, 2, 2. So the total number of elements found in a given set. Okay, so I'll use the examples I have above to explain. Okay, let me add D. So I have 2, 4, 5. Now you have intersection of a set. The intersection of two sets means what is common between the both of them. The intersection of a set means what is common between 2 or more sets, and the intersection of a set is expressed using inverted U. So this is When you see this sign in set, this sign here, it means intersection of what? Set. So from what let me rub off this one. Yeah, I'm done with this. Now from what I have set A, set B, set C, and set D. If you are asked to look for the intercept of set A to B, intercept, what do you do? One is common. Okay, B, right? Okay, no, okay, we cannot use B in this case. We use let's use D. All right. So one, I have one. No, one is not the intercept. Two, two. All right, two. You see that? Four, four. All right, four. Five, five. So this is settled. Then the intersect of A to C. Don't forget we said all the even numbers between 4 and 10. So 6, 8. Okay. I love this. So what do you now call this type of sets? I have 6. I don't have 6 here. I have 8. I don't have 8 here. Therefore, this set is what? A null or empty set. A null or what? Empty set. A null or empty set. You see? So what's the next one? I think we'll just stop there. Yes, that's how it is. Right? If I want to express the union of set A to D, you know what to do, right? So 1, 2, 3, 4, 5. That becomes the answer. 1, 2, 3, 4, 5. You don't forget the union of a set means the combination of the two sets, the combination of the elements of the two sets without any repetition. So please take note of that. Let me conclude by giving you equal set. Equal set. Equal set. So if I have A to be 1, 2, 3, 4, 5. Alright, then I have B to be 5, 3, 2, 4, 1. So the question is A equal to B or A is not equal to B? Let's find out. 1, 2, 3, 4, 5. 5, 3, 2, 4, 1. Equal sets. Because the two sets have the same what? Elements. 1, 1. Good. 2, 2. 3, 3. 4, 4, 5, 5. It therefore means that set A is equal to set B. And this statement is what? Wrong. But if I was having something like this, if I was having maybe 5, 2, 4, 3, maybe 6, I'll say express from this. I have 5, I have 5. I have 5. I have 5. I want to illustrate B equal to C or A equal to C. Let's check if that is correct. B, I have 5, I have 5. 2, 2, 3, 3, 4, 4. So this set is not equal to this set, so I'll strike it. So A equal to C. 1. Okay, good. So it's not equal to C, but A is equal to what? B. When two sets are having the same number of elements, you say the two sets are what? They are called equal sets. So if you have learned something in today's class, endeavor to subscribe, like, share, and comment.